Here in this video, we want to look at Pythagorean theorem. The objectives will be to find the square root of a number, find the unknown side of a right triangle, and to solve application problems. How do we find the square root of a number? And what is it? What is it really? The area of a square is 36 centimeters to the power of 2. What is the length of each side? Area of the square equals the side to the power of 2. So 36 was actually the measurement of one side times itself. So what number multiplied itself to give us 36? Correct. The answer is 6. So 6 is going to be the side of the square. This is how we show it. We show that the square root of 36 equals to 6. Your calculators do have a button which will calculate the square root for you. The square root sign looks like that. That's even exists there, and you can directly press it, or that's on the second function and you have to activate it on your calculators. Sometimes in some calculators you have to press 36 first and then that sign, or you have to punch this sign in first and then the number and then press equal. So please grab your calculator, pause the video, grab your calculators, and try to find square root of 36 on your calculator. What is a perfect square? A perfect square is the product of a whole number times itself. For example, if we take number 1 and multiply it by itself, we get 1. If you take 2 multiplied by itself, we get 4. 3 times itself is 9. 4 by itself is 16. 5 by itself 25. 6 by itself is 36. 1, 4, 9, 16, 25, and 36 are considered perfect squares. And they do have a natural number as their square root. So since 1.1 is 1 times 1 is 1, square root of 1 is 1. 2 times 2 is 4, so square root 4 is 2. Square root 9, 3. Square root 16, 4. Square root 25, 5. And square root 36 is 6. Sometimes when a number is not a perfect square, its square root can only be approximated, and we look at them and work with them in decimal formats in this chapter. And take math later on, you will learn how to simplify these. But at this point, you only put them in your calculator, and your calculator gonna calculate and give you an approximation of the decimal value. You will just replace it. Find the square roots of the perfect square 49 and 81. Find the square roots of 27 and 108. Pause the video, grab your calculators, find the answers, and check them here. 49 and 81 are perfect squares, so square root 49 is 7, square root 81 is 9. Square root 27 is approximately 5.196. And square root 108, 10.392. As you can see, this book is suggesting that we use 3 decimal digits. So just you can round it up or down after 2 decimal digits. I suggest 3. I'll go with that. It's a good approximation for what we will be doing. Now we're going to use objective A to learn how to find the unknown side of a right triangle using the Pythagorean theorem. The Greek mathematician Pythagoras is generally credited for the discovery that the squares of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other 2 legs. And this is called the Pythagorean theorem. So he realized that if you take the measurement of this side, give it the second power, we take the measurement of this side, give it the second power, and add them together, that sum equals to the hypotenuse to the power of 2. What do we mean? In a numerical example, if we have a triangle right down here with the legs 3 and 4 and the hypotenuse 5, hypotenuse was the side right opposite to the 90 degree, and that's the longest side, you can see that if we have 3 to the power of 2, that's going to be 9. 4 to the power of 2, 16. 5 to the power of 2, 25. So how do we get 9? 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And if we add them, you're going to see that they're equal. Let's explain it once more. If the length of one side of a right triangle is unknown, then one of the following formulas can be used to solve it. I don't like us to use the formula much. I want you to learn the process. My suggestion is grab 3, give that the second power. What is 3 times 3? 9. What is 4 times 4? 16. Add them together. 9 plus 16 is 25. Find the square root of that. That's 5. And that is the measurement of that side. So first, take each leg, give that the second power. 3 to the power of 2, 9. Add to that 4 to the power of 2, 16. Add them together, 25. Find the square root. If you had, in this example, if you have the hypotenuse, which is 5, and then you have one leg, which is 4, and the other side is missing, what you going to do? You're going to find 25 and 16. Subtract them from one another, because that's the bigger one. So 25 minus 16, that gives us 9. Find the square root of 9, that's going to be 3. Find the hypotenuse of this triangle shown here. What are you going to do? I'm going to calculate 4 to the power of 2. What is 4 times 4? 16. So write 16 down here. What is 8 times 8? 64. Add 64 and 16. What is 64 plus 16? That's 80. And now find the square root of 80. It must be a little bit less than 9, right? Because the square root of 81 is 9. So square root 80 must be very close to 9. Use this formula. There we go. Square root of 80. Voila. 8.944. If the unit is inches, we're going to keep the unit inch for the measurement of the third side as well. Pythagorean theorem is used a lot in solving application problems. Let's look at this question. A 25-foot ladder is placed against a building at a point 21 foot from the ground. So the ladder is reaching here. You know that if you bring the base of the ladder further on, it's only reaching a lower level, right, on the building. So here's how the ladder is placed. And it's the top of the ladder is 21 feet above the ground. Find the distance from the base of the building to the base of the ladder. So this side is missing. This side is missing. We assume that we do have a right angle triangle here. If that's the right angle, this is going to be the hypotenuse, or the longer one. So you find 25 times 25, 625, write it down here. 21 times 21, write it down there. Do we have to add them or subtract them? Subtract them. Yes, correct. We have to subtract them because we do have the hypotenuse in one leg. Then let me look at the numbers here. (25 to the power of 2 is 625. 21 to the power of 2 is 441. Subtract them from one another. Whatever we got, then eventually we have to find a square root. So we get 184. Square root of 184, 13.565 foot. So the base of the ladder and the base of the building are 13.5, 13 and a half feet apart.